In this example, we're going to combine two things that we have already learned and see if we can figure out the z-score first, then look it up on the z-table. So at the bottom of the screen, I've given you the z-score formula, where z equals x minus the mean divided by the standard deviation. But now I'm going to give you the mean and the standard deviation. Those values are 50 and 4. Those are the values you're going to plug in. So what we could do is actually change this formula to that. X minus 50 divided by 4. You'll see how I've plugged in the mean and the standard deviation because we have a population with those given values. So now what we should do is plug in an x value and find the z-score. How would we do that? Well, for an x of 54, we would plug it into our formula. 54 minus 50 is 4. Divided by 4 is a positive 1.00. It's positive because 54 is larger than the mean. For a score of 58, 58 minus 50 divided by 4 is a positive 2.00. How about 62? 62 minus 50 divided by 4, positive 3.00. What I would like you to do is work through these remaining z-score questions, but as you are doing it, look for the pattern. And here is the pattern that you'll be looking for. One standard deviation is 4, right? Sigma equals 4. So if the x value is 4 points above the mean, such as 54, that's the same as 1 standard deviation. And if the x value is 8 points above the mean, that's the same as 2 standard deviations, because each standard deviation equals 4. 3 standard deviations would be how many points above the mean? 12 points. 3 times 4. And if the value, the x value was, let's say, 1 point above the mean, a 55, that would be a quarter of a standard deviation. So it would be a 0.25 z-score. As you work through these remaining examples, look for that pattern to emerge. If you can spot that pattern and understand it, now you know what you need to know for using z-scores. So let's practice. Pause the video and work out the answers in your notes. Welcome back. Let's see how well you did. An x of 46 is a negative 1.00. 42 is a negative 2. 38 is a negative 3.00. 51, that's a 0.25. It's positive. It's above the mean. 0.25, it's a quarter of a standard deviation. So 52 would be half a standard deviation. 53, 3/4 or 0.75 of standard deviation. We know that 54 is 1 standard deviation, so 55 would be 1.25. 56, 1.5. 57, 1.75. Hopefully you're spotting the pattern. 49 is 1 point below the mean, or 1/4 of a standard deviation, negative 0.25. 48 would be a negative 0.50. 47, negative 0.75. So that is the pattern. We can figure out a z-score given a mean and standard deviation. We plug in a raw score, find our z-score, then we go to the z-table. We can use that z-score to figure out a proportion of scores above or below that z-score, and we can answer some fairly complicated questions. So, if there is a population with a mean of 500 and a standard deviation of 100, what is the probability of selecting an individual at random who has a score greater than 650? Here are the steps. First of all, we would determine the z-score. X minus the mean divided by the standard deviation. 650 minus 500 divided by 100 is a z of a positive 1.50. Now we go to the z-table. What is the proportion of scores between the mean and a z of positive 1.50? It's 0.4332. Now, what we want are the scores above 650 We know that half of the scores, 0.50, are above the mean, and between the mean and 1.5 is 0.4332. So let's subtract. 0.5000 minus 0.4332 leaves that little sliver of 0.668. We could convert that to a percentage by moving the decimal 2 to the right. 6.68% of scores are above 650. So the probability of selecting an individual with a score over 650 is 0.0668, because your probabilities should be in those 4 decimal places. The percentage of scores above that cutoff of 650 is 6.68. Again, if you had any difficulty understanding this example, draw a picture, put a mark at about where 650 would be, and see if you can figure out how these numbers work. I think you have the pattern now. So now we're ready to move on. We're going to learn a little bit of theory, and then we're going to learn about a z-test.